Yes, so we're recording this session. This session, we're actually not going to do anything new. We are just going to do some Q&A. So, quick overview. Here's the things we've done over the last few months. We started with an introduction. We looked at classes, packages, class members. And then we went quite in depth for fields, primitives. We did operations casting, a whole lot of control flow, Java building blocks. We did arrays, methods, and then we saw OOP. We've seen constructor, static, collection, generics. We've seen so much. We've done a lot. And today is a Q&A session. And the topics we will discuss are compiler, static, what does static mean? What is a compiler? And then we'll look at Lambdas more in depth. So we'll see the anonymous implementation from the video because that was a bit unclear. And we will have a look at why to use Lambda. So I will actually tell a little bit about something you wouldn't need to know for the OCA 8 exam, but it does really help in terms of understanding better why you would want to go through all this pain of learning Lambdas and why they're so powerful. So today we don't have homework to discuss. We just have the Q&A questions to answer. So let's move over to IntelliJ and let's start talking about the compiler. So here's just a bunch of code. And this code, that's great, but the computer won't understand it yet. So it needs to be done, this Java language that we've written, it needs to be translated to eventually computer language. Before translating it to computer language, Java is actually translating it to some sort of sub-Java language, the compiled Java. You can actually see them in your own project. We have a folder here, it's called out. And in here, we can see the compiled Java code. And sometimes a bit of stuff gets added or some stuff that we write gets rewritten. For example, if you write a for each loop in your code, you can do one maybe to demonstrate it. The compiler is going to translate this to something different. So let's make a list of birds. There we go. And let's just add, actually we don't even need to add birds to the list to see how the compiler is working. So here, if we would, for example, say for every bird, yeah, no, this is correct, this is Java. In our list of birds, just print the bird object. This is not too exciting, but have a look at this code. And if I'm going to run this project, it's not going to print anything because our list is empty. But, oh, well, let's remove this. And run it again. But what is interesting is to have a look at the compiled code. So this is the code that we wrote. And then, let's see. In here is the code that Java wrote. It's different, right? So this is compiled code. And this code is actually going to be translated, or actually translated once more or a few times more before the computer can actually understand it and execute it. And that's the Java virtual machine that's doing that. That's too much in depth, but just know that compiling means translating code and eventually translating code to computer language. Does that answer your question? Yes, good. Back here, let's get rid of this. So the next question was about static. And well, why is this static? Let's first take a step back and see what static is again. If something is static, it means that it belongs to the class rather than to the instance of a class. So for example, this dog over here, it's a very poorly written class, but it's a blueprint of what a dog should be. And if we have a static, we have a static method in here, and we have a static property in here, that actually means that all instances of dog, they share this, this method or this property. So as opposed to these ones, they're not static. because all the dogs, they have their own weight and they all have their own color. But something that's static, it doesn't belong to the instance, so to the actual dog, but to the concept of dog, so to the bigger pictures. And also if we want to, let's create a dog in our main class. Dog, there we go. Oh, I don't have a default constructor anymore. Let's see what I do have. Oh, that's okay. We can just give a name, a weight, and a color. So let's give our dog a name. Let's call him Java. He's 20 kg or something, and he is brown. There we go. So we've created the dog. If we're going to look what we have method-wise on this dog, we actually don't see these static methods. And that is because they don't belong to the dog instance, but they belong to the dog class. So if I say dog dot, then you can see here that we have this property and we have this method available because they belong to the class rather than to the instance. Does that make sense? Good. So then why is our main method static? Well, something that's static, we can access it without an instance of it being alive. And since the main method is the very access point of our Java application, it's really nice that it's static because we are going to call this before having an instance of main because we don't have an application yet. So let alone we have an instance of something. So we can call this method without having an instance. So therefore our main method needs to be static because it's the starting point of the program before any instance exists. Does that make sense? Any other questions about static? No? Okay, cool. Quick cheat, I think Lambdas are next up. Yes, Lambdas. So one question I just got was this new calculator over here. What's happening here? And also, how does it relate to this, if I understand the question correctly? Well, for starters, our calculator, it's an interface. And we cannot instantiate an interface. So if you would instantiate the interface, we can't, but if we would, it would look something like this. And it's giving the red line because you cannot instantiate an interface. But what you can do, you can implement the interface. We can implement the interface, for example, on our class parrot. Well, that's actually really ugly, but we could say here that our parrot is going to implement the calculator. It would be weird, but it's possible. And if it's going to implement the calculator, we would have to override the method in calculator, which is, I think, calc, and I think it gave back a double, but I'm also not really sure. So it's a void and it's taking one double. It's a very weird calculator, but sure. Void, and it's taking one double. Like this. So now we have a parrot which is implementing calculator. So we can say new parrot, and this parrot, it would also actually be some sort of calculator because parrot implements calculator. So parrot is a calculator. I know this doesn't make any sense conceptually, but that's what we've done now. So this here is overriding the calc. And if we go back to our main, what's happening here is we're actually making an implementation of calculator, calling it C, but it doesn't really have a class it's attached to, but it does override the calc method over here, as you can see, because we do a very similar thing as we are doing in our parrot class. We are overriding the methods. And this overriding is actually implementing the interface on the spot. And if you do that, implement the interface on the spot. So instead of just saying new calculator, but then open the curly brackets, override whatever you must override, you've made an anonymous implementation. And it's anonymous because it doesn't really belong to anything and it doesn't have a name. So you cannot say this, you cannot refer to this new calculator at a later point and make another instance of it. You'd have to type it all again. if that's what you want, you would want to make a separate class implementing this interface. I understand this is quite vague, but does it help a bit? So that's why it's called an anonymous implementation, because I can make now as many new parrots as I want, and they are calculators too. But this one, I can only do once without having to retype all this. So let me get rid of this again. So this is the anonymous implementation, and it's different from making an instance of an object by the curly brackets that follow. So here we have this dog, and with this dog, we are just calling the constructor of the dog, and then we say semicolon. You could do something like this, and then you're actually making an anonymous implementation of dog, giving it some special property. So we can just add some extra method in here. So this is very rarely the good thing to do. But it's possible. I've now made an anonymous implementation of dog, and on our dog D, we can call the extra method. So come on. Or I would assume we could. It's weird. I'd have to look into why this is not possible. Oh yes, because it's not the instance, it's just the implementation. All right. So with this, we are making an instance, and with the curly brackets, we are making an implementation. Does that make sense? Then I think let's see. Yes, so I think the last question is, why would we want to bother using Lambda expressions, right? And that's actually a really good question, because, well, always be critical. Don't just assume that something is going to be useful. But this is actually really useful. We've discussed functional interfaces in the previous session, and functional interfaces are interfaces with only one abstract method in there. And the great thing about these functional interfaces was that we could implement them using lambdas. Now, Java did something really clever here. So they said, well, we are going to define a whole bunch of functional interfaces that we think are very useful. And we are going to use these functional interfaces as input parameters for some of our standard methods. So if we could make, just another few dogs over here. And this doesn't make sense yet. So, oops, hold on. So we have 4 dogs, D2, D3, and D4. I don't know, 3, 4, really heavy dog. And this one is mixed or something. So we have 4 dogs, and I'm going to add these dogs to a list of dogs. And you might wonder at this point, what on earth does this have to do with lambda expressions? And that's a really good question. So what we can do, we can actually say something like this. We can call the for each method. And this for each, it's part of the list or iterable interface, actually. So here we have the for each, and it's taking a consumer as an argument. And consumer is one of these standard functional interfaces of Java. So let's have a look at consumer. And here it says, or consumer, it has one method that is returning nothing and just taking in one parameter of the generic specified. So in our case, this generic would be a dog. And the method is called accept, but we don't even need to see that. So this is called consumer for a reason. It takes something, but it doesn't give anything back. It's just consuming the input parameter, so to say. And that's the standard built-in interface of Java. And on our docs method, we can call for each. And here we can simply say something like, maybe print the name of every dog. Oh, actually, we cannot say D over here because it's specified up there already. So let's just call it dog. Dog. There we go. And if I'm going to run this now, so this is the correct implementation for a consumer because it's taking in one argument, but not returning anything, just does something with it. So if I'm running this, it's going to do something for every dog in our list of dogs. So let's run it, and you'll see that we'll simply print the name for every dog in our dog list. Oh, haha, yes. We would have to add the dogs to our dogs list, right? So let's quickly do that. D2. Like this. We've added all the dogs. And now we are going to say again the for each, and then we'll see that it's going to print all the names of the dogs in our list. So there we go. And if now we would want to have some very different Lambda expression here, so maybe just instead of saying system out print line, we might have, I don't know, some other list here with doubles or oops, ints, I think. This, and then here, instead of saying all of this, we can say something like ints.add and then or dog.get. Oh, it's a double. Like this. So now we are adding something to a list up there. So I can print the list afterwards so we can see that it's doing that instead. So it's very flexible, this for each, because this consumer, we can just implement it using a Lambda expression. And we can do all sorts of things with it. Does this look like magic, or does it actually help and make sense? Or somewhere in between, that's also possible. Yes. Does it at least help to see why it's useful to do Lambda expressions? Yes. I'm going to make it just a little bit more difficult, and then I'm going to shut up. So we've seen this for each, but what we can also do, we can also create a stream of dogs. And a stream, you should really consider it like a stream of water flowing through. But instead of water, these will be dog instances. And with the stream, we can do many things. So the source of the stream is our list of dogs. Then we can do all of these intermediate operations to alter all these dogs on our list. And then in the end, we can do some sort of terminate operation on it to end these streams. So for example, we can say something like make a stream of dogs, filter, and filter is taking yet another functional interface in Java. It's taking a predicate. So let's have a look at this predicate. Oh. This predicate is returning a Boolean and taking in one argument. And the implementation here should return a Boolean. So we could say something like filter, and then we can say anything as long as it's going to return a Boolean and take the T, in our case, a dog, as argument. So we're going to say dog. And then here we can say dog.get name.
Can it also be strings? When you
yes.
filter some information?
Yes, but then we would have a list of strings instead of a list of dogs in this case. But we can use the name of the dog and just say if it starts with a J, then it should pass, and then we can maybe end with a count or something like that. And then here we'll just say long number equals this, and here let's change this dog to Xava or something. And let's also print this. Need spit south number.
What means long number?
This counts method is going to return a long as a result. Long is just the type of our variable number. So we could see this, but this is not working because it's returning a long. So I have to say long is just a potentially bigger number. That's all. So if we run this, we get 3. So what we did, we made a stream of our dogs and then we filtered it. We said, well, we only want dogs to pass that has a name that starts with a J. And then we want to count them. So it's going to kick out Xava, and then this ones will still be in. And then it's going to count them. But we could filter again. We could say, okay, so that's great. Now we want to filter again. And we want to only have the dogs that, I don't know, get weight, and it should be bigger than 20, something like this. We can actually also do this both, so you could just add an end clause to there, but just to make a bit longer function. And then it's now only going to take the ones that have a weight bigger than 20. Oh, that's clearly still 3 because we already kicked out the first. So let's just do this then. And then you'll see there will only be 2 dogs left. And this gets hard to read. So what you often see is that they just do these operations at a new line, so you can easily read it. So we have a dog stream, we filter, and we count. Or you could also say, I want to filter, and then I want to skip 1 dog, for example. Not sure why you would want to do that, but now it will skip the first one and continue with the rest. So only 1 dog will be left in here. Wait. Oh, it's skipping the one of 30. So we should skip 2 in order to get only 1 dog left. So with these streams, and you see them a lot in coding now, you can very powerfully do all sorts of things with your data. And you need lambdas for that.
But firstly, the dog with the X is deleted.
Yes.
In the stream.
Yes,
if it was heavier than 30, it wouldn't be mentioned because it's deleted from the stream with a J.
Yeah, well, if it's less than 30, it gets deleted. So the dog weight is bigger than 30, that one gets through. So it's only having 40 and 50 in there if it weren't for a skip. I can actually show you that. Because I can say peak, which means let me show what's still in the stream. And I'll just say dog get name. There we go. And then it's going to print in between some dog names. So we see which ones are still in the stream. You can see Java 3 and Java 4 are still in the stream here.
Okay. Yes.
Any other questions?
Why are there, by get weight, there are 3 right brackets? The upper? More up by ints?
Oh, here. Yeah, so first one is coming from here. Second one is coming from this add. And the third one are these 2.
Oh, okay. Yeah.
Yeah. Okay. Any other questions?
In the class calculator.
Interface. Yes.
Yes, interface. Why do you only use void calculation instead of public void?
Oh, public is implicit. So every abstract method in the interface is public. So I can type public, but it will be light gray here. And if I hover over it, it says it's redundant for interface methods, because by default, all the abstract methods in your interface, they're public. Same for the static and the default ones. This is because you still need to implement them. And if they're not public, you might not be able to actually access them from outside. Any other question? You, Hella?
No, not yet.
Good. Well, we can still ask questions next week. But if there are no other questions next week, I will tell something about how to prepare for the exam, what books you can use, what software you can use to prepare for the exam.
I have one question, perhaps
Yes.
for next week. Then, with exceptions, it's what I saw is that you have to catch all exceptions. But how do you know exceptions will be thrown?
You only need to catch the checked exceptions. And the checked exceptions, you methods that might throw them, specify them in a throws class. So if I have this, so if I make, let's go to our draw class. And I have the super interesting instance example. I can say that this instance example is going to throw an exception, that it might do that. And right now, this one is actually, it's never going to throw the exception. But in our main, if I'm going to call on our dog the instance example, it's going to say, hold on, because this method, it might throw an exception. It says, and you must handle that. So I can either say, well, it's not my concern, I'm just going to throw it up. Here, I can just say throw exception, like this. This is terrible practice, by the way. But then it's fine. It's like, okay, so it's not my problem to deal with it here. Or if you know how to deal with it at that point, it's better to surround it with a try catch. So let's say try this thing, and then say catch something like this. And then it's fine. Does that make sense?
Yes, but and when you forget it,
you can't, because your codes won't compile. You can't forget it.
Okay.
Because if I would forget it and run my program, it will help me remind I forgot something.
Okay.
Yes. So I can't run it right now. Yes, then I think I'm going to enter a session, right?
Thanks a lot.
Yes, thanks for joining and have a lovely evening.
Nice evening.
Bye-bye.
Bye.